Alright guys, this is task number 2 for this week. This is a little bit heavy on note taking, so if you don't have anything to take notes on right now, go ahead. I skipped the warm-up because these 2 lessons are just kind of long as we're just building the basis for the rest of the school year. So we are now going to be using special right triangles and the idea of a unit circle to be able to find cosine of an angle or sine of an angle or the exact points of those angles all around the unit circle. So the definition of a unit circle is a circle that has the hypotenuse any place on it as 1, any sort of unit on that, 1 unit. And then we always are thinking about this central angle here, theta. And what we want to note is that if I talked about this angle theta, if I wanted to know what this point was, x and y, we're going to talk about how to find that using cosine and sine. So we did cosine and sine when we had special right triangles, but now notice that my hypotenuse will always be 1, so that's my number I'm going by. So here's an example up here. We have this triangle, and they're telling us our angle is 30 degrees. So this is 30, and if it's on the unit circle, my hypotenuse is 1. And they're saying on this slide that I know that my x-coordinate at this point or at this point is going to be cosine of 30 degrees. And why is that? That is because we know that cosine is adjacent over hypotenuse. And so here's the adjacent side right here, and that's my x value. And then we know that sine is opposite over hypotenuse. And here's my opposite from my angle. That's my y value there. So we can now say that x and y is just sine, cosine of the angle and sine of the angle, respectively. So what would it be for a 30-degree triangle? Well, we know that 30, 60, 90 triangle, my short side, which happens to be y over here, is half of my hypotenuse. Or we can say this way, we know my hypotenuse is equal to 2 times my short side. So my short side must be 1/2. So we're going to say that's 1/2 there. And then if you remember, the long side, x, is the short side times root 3. So that's going to be root 3 over 2. So basically, when we are finding cosine and sine using a unit circle, we're really only looking at the value of the adjacent side or the value of the opposite side, because my hypotenuse is always 1, and anything over 1 doesn't change it at all. So we can say that our point up here would be 1/2 and root 3 over 2. And they're both positive because if I'm looking at my x, y axis system, my x's and my y's are positive here in quadrant 1. All right. So pause there, repeat this section if you need to take notes on it. Also, I gave you a couple of unit circles to go ahead and take notes with, so if you were able to print them out, go ahead. If not, pause the video here and make sure that you can copy that into your notebook, because we'll be going over those shortly. All right, so how do we use that? What are the cosine and sine of the angle? And they want the exact values. So first, we're just going to draw a picture. So we just did 30 degrees. 30 degrees is the smaller angle here. Here's 30. And we already figured that out. We figured out that this is the short side. And so if I used my 30, 60, 90 rules and I looked at exact ratios, remember our exact ratios was the short side was 1/2 and the long side was √3/2. And this is just going to be 1. That's why we went through that whole lesson on exact ratios. So my point here, my y or my x is going to be √3/2 because you can see the x point is the long side and the short side, which is my y value here, is 1/2. All right, so that's that point. All right, the next one is 300 degrees. So we got to figure out what coordinate we're going to be in. So here's 90 degrees, here's 180, here's 270. So 300 comes here in this fourth quadrant about 30 degrees past 270. So if this is 30, then this must be 60 degrees. So we know this whole thing here is 300 degrees. So we're going to use the 60 degrees to figure out what our value at this point is, what our x, y is. All right. So I'm going to draw my vertical side up to the nearest x-axis. So don't be tempted to draw it like this. That's not how it goes. It always goes to the x-axis. And we know that cosine of this point, or x, the x-coordinate of this point is cosine. So if this is 60 degrees, a 30, 60, 90, the long side across from the triangle is that √3/2. So that looks like that's what our y value is going to have in it. And the short side, or the x point right here, is 1/2. Now we just have to decide in this xy axis quadrant, so this is 1, 2, 3, 4, are they positive or negative? So we can see over here in quadrant 4, my x values are always positive. So down here, I'm going to have my x value of 1/2, and that's positive. But notice that y values down here, we're negative. So this is going to be a negative √3/2. And just remember, I have office hours every Tuesday, Thursday at 1 o'clock. Or if you need to meet at another time, just say, hey, Mrs. Ice, can we meet, you know, Monday at 2 or Wednesday at another time, and I'll see if I can make that. I do have staff meetings we have to go to, but those are just usually on Wednesdays. All right, so now we finally have 225, and if we know this is 180 degrees to here, then 225 is going to be between 180 and 270, and it's actually going to be exactly halfway between, and we're looking for that point there. 225 is 45 degrees, so this angle here is 45 degrees past 180. And if we remember our exact ratios of 45, 45, 90 triangles, we know these two sides are equal, and if this was 1, then these two sides were √2/2. So what you're noticing is there's only a few values our cosines and sines can be. And we know that these x and y's are going to be some version of √2/2. But notice over here my x values are negative, so my cosine of 225 is also going to be a negative √2/2. And my y values down here are also negative. So then I'm going to put it in like that. All right. This really is the key to filling out the unit circle here. So take a moment, pause, take down your notes on this, because next we're going to go just fill them out. And we're going to go kind of quickly just because it's a video, and the longer it is, the harder it is for you to upload it and for me as well. All right, so here we go. So you should have one of your unit circles, if you were able to print it out, that just has the angles on it, and it looks like it wants all the sine and cosine, which remember that's my x values and those are my y values. So here at 0 degrees, my x value is 1, notice, and what's my y value? It's 0. So we're just going to fill that in. We already did our 30 degrees. We know that the long side was the x side and the short side was y. For 45, there's only two values it can be, or only one value it can be, is root 2 over 2. And in this quadrant, they're both positive. All right, and now at 60 degrees, my x is my short side. Everything over here is positive, so that's 1/2. And then my y value is my long side. And then to finish out quadrant 1, up here, my x value is 0, but now my y value is 1. These are the only values you're going to see all the way around the unit circle. It's just some of them are going to be positive or negative depending on the quadrant. So now we move over here to quadrant 2. My x values are all going to be negative over here, except for y value will be positive. So 120 is parallel with 60 degrees. So my values are going to be the same, but the signs change. So this is going to be a negative 1/2 and a positive root 3 over 2. This is equivalent with my 45 degrees. So I'm going to have a negative root 2 over 2 for my x value and a positive root 2 over 2 for y. And then I come over here, this is equivalent with 30. It's just that my x value is negative in this quadrant, so negative root 3 over 2 and a positive y value of 1/2. Over here, my x is negative 1 and my y is 0. If you wanted to, you could go ahead and pause this and see if you could finish up the unit circle. Otherwise, I'm just going to go through and fill them out. Again, this is my 30 degree, but now they're both negative, so negative root 3 over 2 and negative 1/2. This is my 45, so they're both negative in the third quadrant. Down here, this is my 60 degree, so they're both negative here. Down here, I'm going to have a 0 for my x and a negative 1 for y. When I move into my fourth quadrant, my y's stay negative and my x values become positive. And so notice that this is my 60 degrees here because they are parallel. So we have a positive 1/2 but a negative root 3 over 2. This is my 45 degree angle, so a positive root 2 over 2 and a negative root 2 over 2. And over here, this is my 30 degrees. And so we're going to have a positive root 3 over 2 and a negative 1/2. And you can pause and finish that if you'd like. All right. Moving on. The last thing is converting from degrees to radians or from radians to degrees. So you're going to want to make sure you get this formula up here. So put that in your notes. Take a picture of it. So if we were going to do that here, what is the radian measure of a 25 degree angle? So to convert from degrees to radians, we would want the pi to be on top when we multiply. So I'm going to have 25 times pi all over 180. That's how I convert it to radians. So I would get 25 pi all over 180, and then I would want to reduce. So I'm going to see if they're both divisible by 5. I know that 25 is divisible by 5, but 180 divided by 5 is 36. So this would reduce to be 5 pi over 36. For radians, I never want to see a decimal. I always want to see the ratio with pi in there. And that is because when we go to convert them and fill out our unit circle, we want to start getting used to what's equivalent to what. All right. So you had a second unit circle. The only thing we're adding in here is we're converting the degrees to radians. So I'm going to go through the first quadrant a little more slowly so you guys can get the idea. So like 30 degrees, if we want to convert that to radians, it's 30 times pi over 180. 30 goes into 180 6 times, so it's pi over 6, right? So this angle here is pi over 6. If I did that with 45, I would see that it was pi over 4. And if I did that with 60, the same conversion that I did up here, this would be pi over 3. Now I always divide my unit circles according to different sections. So here we have 1 pi over 4. So we're just going to do all the 45-degree angles. This is 1 pi over 4. This is going to be 2 pi over 4, which reduces to pi over 2. This is 3 pi over 4. That does not reduce, so we're going to put that 3 pi over 4 in there. And this is 4 pi over 4. We're 4 pi over 4. That simplifies to be just pi. So we come down here to 225. That's 5 pi over 4. This is going to be 6 pi over 4 down here at 270. That reduces to be 3 pi over 2. And if this was 6 pi over 4, then this is 7 pi over 4. And over here at 0, 0 gets fancy. It gets to be 0 radians if I'm starting, but if I'm ending, 2 pi. So 2 pi is equivalent to 360. So then I do the same for the pi over 6's. This is 1 pi over 6, 2 pi over 6, but I already have a value there. 3 pi over 6, I've already reduced. 4 pi over 6, that reduces to be 2 pi over 3. This is 5 pi over 6, that does not reduce. This is 6 pi over 6, but we already have pi. Here's 7 pi over 6, that does not reduce. This is 8 pi over 6, which does reduce, so 2 goes into both 8 and 6, so we have 4 pi over 3. We already have a value here at 9 pi over 6. This is 10 pi over 6. 10 pi over 6 is going to be 5 pi over 3. And last but not least, we have 11 pi over 6, which does not reduce. So that's how I fill it in without memorization. You guys are not going to need to memorize this, so just make sure you have this all in your notes. It'll be very helpful for your assignments tonight. All right. Thank you for doing your best with learning this way. It's not ideal for sure. That's it.